Starting from this video, we will shift our attention to cast iron pipe. In fact, not all piping systems need pipes designed to withstand the extreme conditions found in process piping facilities. Cast iron pipe, which has been in use for centuries now, is used primarily in gravity flow applications such as sanitary sewers. Residential, commercial, and industrial facilities are usually built with some form of gravity flow systems. The corrosion resistance properties of cast iron pipe make it the ideal product for permanent, below-ground, gravity flow installations. Now, the term cast iron refers to a large group of various metals. Cast irons are primarily alloys of iron that contain more than 2% carbon and 1% or more silicon. Cast iron, like steel, does corrode. But what makes cast iron different is its graphite content. As cast iron corrodes, insoluble layers of graphite compounds are produced. The density and adherent strength of these compounds form a barrier around the pipe that prevents further corrosion. In steel, this graphite content does not exist, and the compounds created during corrosion cannot bond together. Unable to adhere to the pipe, they flake off and expose an unprotected metal surface that perpetuates the corrosion cycle. In tests of severely corroded cast iron pipe, the graphite compounds have withstood pressures of several hundred pounds per square inch, although corrosion had actually penetrated the pipe wall. So, considering the low cost of raw manufacturing materials and the relative ease of manufacture, cast iron is the least expensive of the engineering metals. These benefits make cast iron the choice application in environments that demand good corrosion resistance. Cast iron pipe is grouped into two basic categories. These are hub and spigot and hubless. The hub and spigot joint uses pipe with two different end types. The hub end of the pipe has an enlarged diameter, thus resembling a bell. On the other hand, the spigot end of the adjoining pipe has a flat or plain end shape. The spigot is inserted into the bell to establish a joint. Two methods of preventing leaks on bell and spigot joints are compression and lead and oakum. The compression joint uses a one-piece rubber gasket to create a leak-proof seal. As shown in this figure, when the spigot end of the pipe is placed into the hub containing a gasket, the joint is sealed by displacing and compressing the rubber gasket. The following zoom focuses on the gasket and illustrates how the sealing is made. Unlike welded pipe, this joint can absorb vibration and can be deflected up to 5 degrees without leakage or failure. The lead and oakum joint, as in this example, is made with oakum fiber and molten lead to create a strong, flexible, leak-proof, and root-proof joint. When the molten lead is poured over the waterproof oakum fiber, which is a loose packing material, the joint becomes completely sealed. Water will not leak out, and when used underground, roots cannot grow through the joints. To better illustrate how this special sealing method is used, let's have a look at the following demonstration. The next group is the Hubless cast iron pipe. Hubless cast iron pipe uses pipe and fittings manufactured without a hub, as in this example. The method of joining these pipe and fittings uses a hubless coupling that slips over the plain ends of the pipe and fittings and is tightened to seal the ends, as depicted here. The following video shows a simplified installation procedure. Finally, keep in mind, Hubless cast iron pipe is made in only one wall thickness and in the following diameter ranges.